Hello everybody, welcome to the OpenThread 101 series, and this is part 7. It's a continuation of part 6 where we set up the Wireshark, and now in this video we will proceed with our setup so that we can basically decrypt and decompress the packets, because in OpenThread the packets are encrypted as well and they are compressed as well using the 6LoWPAN. So in this video, we will just start directly with Wireshark. So I will open Wireshark here. Let's minimize this so that we can see our windows a bit clear. So here in the interfaces, you see the NRF sniffer. So if you have this configured in the previous video, it should be fine. You can just double click here to start capturing, and we would not see anything here. So let's bring one of the device online, and we would basically open VS Code, and I will turn on one of the device so that we can see some packets here. So the device 2 is online, and let's connect with this port. Let's move the terminal window into a new window so that we can see Wireshark and the UART and the same screen. So our device should have the dataset ready. So we would bring up the interface and start thread network, and then as you see now, we start seeing packets here. These packets, the protocol is MLE, which is Mesh Link Establishment Protocol. I think it's Mesh Link Establishment Protocol. Mesh Link Establishment Protocol. So this protocol is used to by OpenThread so that each device knows its neighbors. And currently, if you look at the packets, our device is broadcasting these packets, and the broadcast address, the destination FF02::2 means it's a group address or a multicast address for routers. So any router on the same link or would respond to this message. So any router who can see this message, these messages would respond. Our device sent these messages for a while now, and then it stopped sending them, and now it is sending broadcast messages to all nodes. So it is broadcasting a message to every node in the neighborhood. So any node that can listen to this message can respond to it, and then they can establish a link. So this is why Mesh Link Establishment Protocol is doing. If you want to look into the content of these messages, let's have a look at this. So it's a frame. So frame is basically the physical layer, and then we have in the Wireshark, the packet is, the view is kind of similar to how you would see it when you are looking it through the OSI model. So here is the frame, or basically the link layer. So and here you have the IEEE 802 layer. So this is another protocol, and here you would see that some of the information are displayed here. And then you have on top of IEEE, you have 6LoWPAN, and here you have again this information displayed here that is extracted from the packet. Then it's an IP packet, and inside the IP, then it's a UDP packet, and then on the UDP it's a Mesh Link Establishment. So it's a Mesh Link Establishment protocol, and here it says warning, undecoded, no encryption key set, cannot decrypt. So I think this message is I don't know if the packet is encrypted at this level yet, but maybe, I don't know, maybe this can be wrong, false flag, or it is just that currently we don't have the encryption key set, decryption for the key for decryption set. That's why it's doing this. But again, these messages are then being broadcasted, and then again we have the messages for broadcast message for all nodes. So our device is basically constantly trying to discover whoever is in the in its range, and this is how in thread a device basically would look around constantly to see if there is anything in the range that can talk to it and establish links with that. So if you look into our device now and we do OT state, it says it is leader, so basically our device is now serving as leader of our network. Now what we can do is bring up another device so that we can see what happens when you have two devices. So we would turn on our second device, and in the VS Code I will open the UART for the second device, move it to a new window so that we can see it better. I will just leave it as tabs in the same window, clear, and then what I would do is basically OT config up, and then OT thread start. So our device should start looking for routers. So here it saw a router. So basically let's see what's going on here. So if we OT state, it is currently detached. So before, all the way here, 756D is a device, and then here 59F4 comes, and he is asking if there is any router in there, and I don't know if we can follow this packet UDP stream. No, we cannot follow it, so I guess it is not intelligent enough, or I don't know, maybe we just don't understand it in detail enough. But basically what's going on is this device is the broadcast, this is the normal broadcast from this device, and our device F4 is sending router message, router, and then here we receive a response from another device to our new device, and we don't know what kind of packet this is, so it's currently seems encrypted, and then we have the acknowledgement, and the source and destinations are not visible here. Maybe it's not there, some compression going on. But you see here that our devices are talking to each other. Some of the information is encrypted here, so let's fix this. Hopefully once we are done, then we would be able to see a bit more information. So I will turn off both of these devices, and we'll just do the configuration that we need. Okay, so probably we would need to turn on one of the device so that we can extract some information that we need for here. So the first information thing, so the first protocol that we need to configure is 802.15.4. so in the here it is IEEE 802.15.4. Here you would have to configure the keys here. So here we enter the key type is thread hash decryption key index 0, or This can be 1 as well, or doesn't matter, I think. And then we have a decryption key. So here we need the network key for the network that we want to listen. So let's have a look at the device 2 OT dataset active, and here we need this key. So this is the encryption key. So this one is done, and the other one is we need the mesh local prefix for our 6LoWPAN configuration. So we would go to the 6LoWPAN now, and here in context 0 we would enter this one. Here we can also add something for context 1 as well, but we don't have that information at the moment. That is on mesh prefixes. That is when the device is connected with the internet with the border router, and then the border router provides those unmesh prefixes. But currently we don't have a border router, so we will just enter one entry, and this information is then used to decompress the packets. And so this should be good enough. So let's start capturing again. So we would not see anything at the moment because our device is not online. So what we would do is OT config up in OT thread start. So now we see that our device is asking if there is any router in the neighborhood. And if we look at the data now, the mesh establishment link and the user datagram protocol, you see that there is no warnings that the data is encrypted and it cannot see it. So we can see all the information that is there. And this is how we configure. I think for this video, this is again enough. And we would go a bit more into details about how two devices talked with each other, and we would sniff some different stuff and play a bit more with it. Thank you very much for watching. I hope this video was good enough, and I will see you in the next one.